So one of the things I always tell, my clients or my beginners is always, it's not fractions, it's not percentage, it's proportion, right? If you want to sound like like a professional statistician or professional data scientist, we use proportion. So keep that in mind, guys. It's just one of those things that when I learned that and when I adopted it, it felt like it elevated your career, your status, right? We don't say fractions, we say proportion. Osama says turning off parts of neurons during each training iteration. Yeah, yeah, Osama. I think you're on the right track there, in line with all the other items. But again, guys, just remember, it's just another extension of simulating the human brain. The human brain is not perfect. You're going to forget things, right? But your brain doesn't say, "Oh, I forgot that. I'm never going to think about it again." Your brain finds other ways, other connections, right? Same thing. Same thing. All right, guys. So number 4, I want to talk about real briefly. We're going to have multiple nodes in the output layer. Because if you remember before, we were using our XOR, right? We were using our XOR table as our data to be able to say, hey, this is the input and this is the desired output, right? 0, 1, 1, or 0. So that's basically a binary output. And we were only getting one probability, right? This probability here that tells you whether it was 0 or 1. So here, this is telling you it's 998. That means it's closer to 0. That's closer to 1, excuse me. So the likely answer is 1. Here, it's 0.004, which is close to 0, which means that the likely answer is 0, right? But what happens when we go beyond ones and zeros? It's kind of important, right? So when would we need to do that? We are going to work on what is known. By the way, guys, I'm sorry if I'm mispronouncing this, but I've always referred to this as the MINCE data set. Maybe I'm wrong on that. If somebody wants to correct me on that, but I've always referred to it as MINCE. If you've never heard of this data set, it's basically a collection. Oh, actually, no. Let me increase this. Sorry, guys. It's basically a collection of images, and those images are handwritten numbers. So what we're going to do is we're going to take, this is going to be our data, and we are going to create a neural network to determine an input picture and say, what number is this? Right? So, taking everything we know about neural networks and all that, how many nodes are going to be in our output layer? We want to keep an open mind to what our architecture is going to be and all that. But one of the first things you should establish in a neural network design is your output layer, right? Because that gives you an idea of the complexity and the time it's going to take you, all that stuff. Put it in the chat. How many nodes are in our output layer? All right. So Yassine, Starry Vibes, Denelson, Michael, everybody's coming up with 10. Okay, why? Denelson says 1 for each type of number. That's exactly right. Thank you, Denelson. That's exactly right, guys. So if that's not clear to you, we're basically saying we're going to have a neural network. And these are the possible results from that neural network. Or as Yassine says, we have 10 classes, right? Each one of these numbers represents a class, right? So we have to assign a probability to each one of these classes based on what our neural network knows. So speaking of complexity, right? You as the data scientist should immediately be aware that, hey, this is going to be a little bit more complex than your average model, right? Because if you're going to have 10 outputs, that means you're going to have a fairly sizable model, right? Because, 10 outputs, you're unlikely to reach a good answer with only just a couple of layers. You're probably going to need multiple hidden layers. Each one of those layers, you generally want them to be bigger than the number of outputs. Maybe just as a starting point, we'll use 30 nodes. I mean, I'm making that up because any answer is valid, right? So right away, you should be knowing, oh, wait a minute, this is going to be a serious effort, right? Some of the biggest models that I've worked on, I think, have been up to like 46 or 48 different classes, right? Which is a lot, right? You know that you're going to be investing into a serious model when you're doing that. But I'm bringing this up because these are the types of like mental calculations that you can make just by talking to stakeholders, just by sitting in general meetings, right? You don't need to code everything out. You don't need to um, run experiments. This is more about like just kind of like the experience side that you develop as a data scientist to say, wait a minute, there's a big difference between me developing something that has 3 or 4 classes versus 15 classes, right? I mean, think about what this looks like for the American, or rather the English alphabet. English alphabet has 26 letters. So now you're going to have 26 classes, right? So what does that look like? Well, that's a big network, right? So I'm encouraging you to kind of think about it in those terms, because this is how you can come up with like ballpark figures to know like, okay, wait a minute, that's going to be a pretty significant effort. I need to be careful here on the questions I'm asking and make sure I have enough data, because the more classes you have, generally speaking, the more data you need, so on and so forth, right? So keeping that in mind, we're going to be working on a neural network that most likely will be image data, which most likely, or we'll start with CNN. We're going to use a modern framework instead of raw code, and we know that our output layer needs 10 nodes. Okay? Are you guys with me so far? If anybody's lost, that's okay. Let me know in the chat. But otherwise, let's go ahead and start going into ChatGPT and start building out this sucker. All right. So give me just a second, guys. Let me bring up I guess we're ready for the web. Oh wait, we are in the web interface. Okay. I think we are gonna stay with O4 Mini. O4 Mini has given us pretty reasonable results so far.